Okay, they finally asked us to use the definition of derivative to find f prime. We're getting closer to using real calculus. In fact, this is the worst part of calculus because you have to do the most actual algebra. What was that? You should know this formula by now. I'm writing it a little bit sideways. That's a minus sign in there in case it's hidden. And let's do this bottom one first because it looks pretty ugly. But I'm going to write it as, in fact, we don't even need the f function. Let's just write it out. F prime of a is going to be 4 over the square root of 1 minus x plus h minus 4 over the square root of 1 minus x, all divided by h, like that. And we're going to need to use a common denominator, so let's take this here and we'll put it on top and bottom here, and vice versa for this guy's got to come up here and down there. So that's going to be 4 rad 1 minus x minus 4 rad 1 minus x minus h. See how I distributed that? You got to be careful. Over, let's put this h in the front of the denominator here, and then we have rad 1 minus x minus h, and we have rad 1 minus x. Okay, let's take this 4 out, and we'll just do this. It's getting warmer. You may remember from doing our conjugates in the last couple lessons and back in algebra when you're supposed to learn it, that a plus b times a minus b gives you a squared minus b squared with no middle term. That's good to know. So let's take a look at what we can do with that here. We'll put this on top and bottom. Rad 1 minus x plus rad 1 minus x minus h, like this. And now I'm going to get real lazy. I'm going to grab my freeform select. Or I'm not. What happened there? I think I got it this time. Let's see if I can do this. Put it on top and bottom. I'm being lazy. Let's just write it out. Okay. Now these are not conjugates, so they can't combine exactly, but the ones on top can, so the rads are going to kind of just disappear, and we're going to get a 4 times 1 minus x and 1 minus x minus h, like that. These are supposed to be minused, aren't they? Yes, they are, because it's a squared minus b squared. This is right. Thanks for the correction, guys. I know you were watching there. And then we'll deal with the denominator in a second here. So you'll notice that a lot of these are going to cancel because you get a minus 1 and a plus 1 and a minus x and a plus x. So we're going to get a 4h on top. And that means 4h over h times rad 1 minus x minus h times rad. I'm just putting these parentheses in to make it easier to see. And then on this side, there's an addition. So it's not exactly a conjugate because these aren't minused. Right? Don't make that mistake. Okay. I see at least this cancels. So I don't think there's any more cancellation I can do, so I'm going to give it a try where we finally put in 0 for h, now that we're not going to have a divide by 0 over 0 kind of a thing. So maybe I take this out. I'm going to take this out. And we get 4 over rad 1 minus x rad 1 minus x times rad minus x plus rad 1 minus x. This is weird. This whole thing is in the denominator. So we can distribute, right? And I would write it as 1 minus x to the 1/2, because rads are dumb. And when they're multiplied straight across, like this, they don't multiply the exponent, but they simply add. So we'll see what that does. Okay, so this right here would just be a 1 minus x, right? Half plus a half is a whole. And that would mean this would add up to 3/2, so I'll get 1 minus x to the 3/2 for that part, plus 1, 2, 3 over here to the 3/2 on that part. This is why you don't want to use radicals. Exponents make it better. So that would be 2. So I think our answer, there's no way this is right, is going to be 4 over 2, 1 minus x to the 3/2. And then we can do some cancellations. So we should get 2 over 1 minus x to the 3/2. That one is so exhausting, I'll tell you what, let's just make this the video part right here, and I'll do the next 2 problems in the next video.